of rule. Markovnikov rule आपको apply करना है. Hydroxyl group attached on that carbon which has less number of hydrogen. Just remember that. Okay, in unsymmetric type of alkene. Okay, so we have
Yeah.
we were discussing the questions. Okay, so I think this topic is clear now. We should further move to the next preparative method, which is your hydroboration oxidation reaction. This is again from the alkene. We will prepare the uh, alcohols, corresponding alcohols from the alkene. And this method is basically known as hydroboration. Hydroboration oxidation reaction. Oxidation reaction. Okay, write down the heading. Yeah. So hydroboration. What is hydroboration? तो इसमें हम use करते हैं बोरेन और डाइबोरेन. Borane BH3 or diborane B2S6. Right. So this is a two-step
Yeah.
process. This is a two-step process. In the first step, hydroboration होता है in the presence of BH3 or B2S6. Okay, and in the second step, oxidation. Okay, and basically these two-step process, it is used to convert an alkene into an alcohol. Okay, so basically क्या होता है? Basically, let's see. So hydroboration oxidation reaction is basically the addition of borane in the first step, followed by oxidation, in the second step is known as hydroboration oxidation reaction. Okay. Now see what happens in this. So basically, suppose if we take alkene, okay, unsymmetric type of alkene. So in the presence of B2S6, okay, diborane, और आप simple BH3 भी ले सकते हो, borane भी ले सकते हो. Okay, in the presence of, and yeah, B2S6, it is taken in the presence of THF. THF हम solvent, THF is basically a solvent which is tetrahydrofuran. Tetrahydrofuran, इसका structure कुछ ऐसा होता है. Tetrahydrofuran, right? It's a Lewis base which acts as a solvent and it forms a complex with a Lewis acid. ये क्या करता है? THF ये complex बना लेता है B2H6 के साथ and वो complex
Okay.
इसके साथ react करता है. That complex helps in the boration. Basically, addition of borane में help करता है to the alkene part. Okay, so this is tetrahydrofuran THF, right? And in the second step, the addition of borane, which is followed by the oxidation. And oxidation किसके presence में होता है? Hydrogen peroxide in the basically NaOH, sodium hydroxide के presence में, right? So what happens here? The OH group, hydroxyl group attaches on that carbon which has more number of hydrogen. Right, this is a symmetrical type, right? Now you can see over here, hydrogen is, how many hydrogens are there? Tell me, this carbon.
In this carbon, there will be two hydrogens.
Yeah, to this carbon,
That carbon, one hydrogen.
one hydrogen. So basically, in hydroboration oxidation reaction, we apply anti-Markovnikov addition. Anti-Markovnikov हम rule apply करेंगे. And what is anti-Markovnikov addition rule? The hydroxyl group will attaches to that carbon which has more number of hydrogen. किसके पास hydrogen ज्यादा है? This carbon. Right? This
Yes.
has two hydrogen and this has one hydrogen. So simply you have to attach the hydroxyl group here on this carbon. Okay, so this will give you the corresponding alcohol. So that's a hydroboration oxidation reaction. Now see, this is basically, ये तो हमने लिख लिया, this is a reaction. Now let's see what is the mechanism for this reaction. What is the mechanism for this reaction? So in the first step, basically यहाँ पे हम 3 moles लेते हैं. 3 moles of CH3, CH, double bond. This is your CH2. Okay, when you add in the first step, when you apply B2H6, okay, और आप BH3 भी ले सकते हो, no issue. Okay, diborane or BH3, BH3 you can write. So what will happen? यहाँ पे क्या होगा? So it will form a complex over here. CH3, CH2, ये double bond होगा. ये क्या होगा? ये break हो जाएगा and it will form corresponding alkane. Okay, this is 3 moles. तो 3 moles यहाँ पे आ जाएगा and this bromine and this boron. Sorry. Plus, now this is the first step. What happened in the first step when you take the 3 moles of your corresponding alkene and you treat it with your borane? So what will happen? You will get the addition. Addition of borane will be there, right? And in the further step, in the second step will be the oxidation. जब आप H2O2 लोगे hydrogen peroxide in the presence of sodium hydroxide. So sodium hydroxide will give you OH minus ion, right? So what will happen over here? So it will form corresponding alcohol. 3 moles of CH3, CH2, CH2 and OH. And your byproduct will be your BOH. Okay. So first step is always the addition of boron. Okay, and the second step is the oxidation. Oxidation in the presence of hydrogen peroxide and in the basic medium NaOH presence. Is it clear?
Yes, ma'am.
Okay. Yeah, you can write down. In this reaction, okay, no need to write down because आपने mechanism समझ लिया तो mechanism लिखने की जरूरत. Right, so just remember in this reaction, this propene reacts with borane or diborane to form trialkyl borane. ये क्या है? This is a trialkyl borane, right? And this
Yeah.
trialkyl borane further oxidized to alcohol, okay, by hydrogen peroxide in the presence of aqueous sodium hydroxide. In the presence of aqueous sodium hydroxide. Okay, write down so you can remember this. In this reaction, propene reacts with diborane, borane, borane to form trialkyl borane as an addition product. As an addition product. Further, this addition product is oxidized to alcohol by hydrogen peroxide. In the presence of aqueous sodium hydroxide. Now see examples. Okay, suppose we take first example. Butane. When it undergoes hydroboration reaction, first step. In the second step, hydrogen peroxide in the presence of basic OH minus ion. Now tell me what will be the product. And the second question is we have this molecule. These two. Mhm. Okay, tell me what will be the product in both the cases. In hydroboration
Oh,
oxidation reaction, you are supposed to apply the anti-Markovnikov of addition rule, and in the previous means your acid catalyzed reaction, उसमें क्या करना था आपको Markovnikov rule लगाना. So just remember.
yeah.
Just tell me the product. Ahil.
Ma'am, the first product will be the same carbon chain, but with the double bond removed and OH attached, right?
Yes. And the second one,
The second one, it'll be the same, right? Double bond
suppose
remove OH.
suppose if this is your carbon one, this is a carbon one.
Yes,
Then tell me
yes.
hydroxyl will OH will be attached to which carbon? One or two?
Ma'am, over here, both the carbons have same number of hydrogen, right? Or no?
No. See,
One,
this
two,
this
one hydrogen.
carbon has one hydrogen, right?
One
And this
hydrogen,
carbon
yeah.
has one, two, three, four. Four bonds are there,
Oh,
means zero
yes.
hydrogen. इसके
Zero
पास
hydrogen,
zero
yeah.
hydrogen है and इसके पास है one hydrogen. So obviously the hydroxyl group will attach to this carbon position where the number
Yes,
of hydrogen is more. तो आप यहाँ पे attach
yes,
करिए. This will be your product. Yeah, so is it clear?
yes, ma'am.
Okay, so that was from the alkene. So from alkene, we can prepare the alcohol by two methods, by acid catalyzed reaction, and the second one is by hydroboration oxidation reaction. Now the second method of preparation is from alkyl halide. From halo alkene भी आप लिख सकते हो और alkyl halo alkenes. Yeah, so that's very simple. So when alkyl halide RX, okay, haloalkene, when it is treated or in the presence of aqueous NaOH, sodium hydroxide or KOH, what happens? What happens? It will give you corresponding alcohol. It's very simple. So it will give you ROH plus your KX. KX अगर आप sodium NaOH use कर रहे हो तो you will get NH, NX, right? And when you are using potassium hydroxide, so you will get X. Now, for example, if we have CH3, and tell me, Ahil, which type of reaction it is? It is SN2 type of reaction. इसका mechanism क्या होगा? SN2 type of, this is a nucleophilic substitution reaction, right?
Yes,
So
ma'am. Yes.
this is CH3 Cl. Suppose this is CH3 Cl, and in the presence of aqueous KOH, what will happen? This will give you OH minus. Okay, this is a nucleophile over here. So
Yeah.
this is a good leaving group. This is more electronegative. तो ये क्या करेगा? ये leave हो जाएगा and this OH will attach to this carbon, right? And you will get CH3OH plus your PC. Okay, that's the example. And this is your SN2 type of reaction, nucleophilic substitution reaction. It's very simple now. Now suppose another example. If we have, yeah, in the presence of aqueous KOH. So what will be the product?
This will be yeah,
Tell
so it'll
me
be
quickly.
the cyclohexane with OH attached in the position
Yeah. So this
and
chlorine
plus
is a good
KCl.
living group. Yes, very
Yeah,
good.
so plus
OH
KCl.
का OH is a nucleophile, तो यहाँ पे
Yeah.
अटैक करेगा and you will get Ks. Yeah, so see in this halo from haloalkanes, basically tertiary haloalkanes gives a mixture of alcohol and alkene, right? That's why tertiary haloalkene से हम alcohols नहीं manufacture करते. Why? Because it is not a preferred method of preparation of tertiary alcohols. Why? Because it gives a mixture of alcohol and alkene. वहां पे आपको क्या मिलेगा? Mixture of alcohol and alkene. Because tertiary
Ma'am,
alcohol, yes,
ma'am, could you explain that point again? I didn't understand.
yeah, just a second. First, write down the note. Tertiary haloalkanes gives a mixture of alcohol. को alcohol भी मिलता है उस केस में and you will get the alkene also. Okay, on treatment with aqueous KOH or aqueous sodium hydroxide. So it is not a preferred. That's why we don't prefer tertiary haloalkanes for the manufacture or for preparing tertiary alcohols. Now see what happens when you take the tertiary haloalkane. Suppose we have CH3, CH3 over here, CH3, and यहाँ पे कोई भी आपका X, right? If you take the tertiary haloalkanes, so you can see there are bulky group. यहाँ पे bulky group attached, right? So यहाँ पे bulky group attached है. So when you treat it with aqueous KOH, what happens? यहाँ पे न्यूक्लियोफिलिक सब्स्टिट्यूशन नहीं होके यहाँ पे एलिमिनेशन रिएक्शन हो जाता है. यहाँ पे एलिमिनेशन रिएक्शन हो जाता है. Suppose if you are using KOH over here, what happens? What happens? यहाँ पे suppose so it will give you a corresponding. This will be removed and यहाँ पे क्या आ जाएगा? Plus charge, right? And we know that carbocation, tertiary carbocation क्या होता है? Tertiary carbocation is, suppose it's more reactive than secondary than primary. So in this case you will get the mixture of alcohol. Just remember इसमें क्या होगा? आपको mixture of alcohols and alkenes मिलेंगे. आपको यहाँ पे alkenes भी मिलेंगे, right? So that's why यहाँ पे क्या होता है? When you treat the tertiary haloalkanes with aqueous potassium hydroxide या aqueous आप ले लो sodium hydroxide, so you will get the different mixtures मिलेंगे. तो you will not get the what you are trying to manufacture. Like आपको alcohol चाहिए, सिर्फ alcohol चाहिए, तो you will got the mixtures. So after that, for you will need to you will basically वहां पे आपको further purification की need होगी because आपको mixtures मिल रहे हैं, right? You will not get the product which is required. आपको सिर्फ alcohols बनाना है वहां पे, not the alkenes की need नहीं है. That's why ये बनता है. This is a method of preparation, but it is not preferred. Why it is not preferred? क्योंकि questions में ये आएंगे नहीं, बस ये याद रखना क्यों preferred नहीं होता है. Because you just get the mixture of alcohol and alkene. वहाँ पे alkene का भी formation होता है. So that's why tertiary haloalkanes gives a mixture of alcohol and alkenes. That's why this is not preferred method of preparation. Clear?
Yeah. Okay, ma'am.
Write down then if needed मैं explain करती हूँ mechanism. Just write down the point and let's do some questions on that.
Oh, yes, ma'am, I wrote it down. I'm done writing, ma'am.
Okay. Okay, right on the next one. Okay, so in this you just have to remember that यहाँ पे क्या होगा, substitution reaction और elimination reaction भी होगा. Basically यहाँ पे क्या होता है, when you take the haloalkanes when you treat it with aqueous potassium hydroxide or sodium hydroxide, तो वहाँ पे आपका nucleophilic substitution reaction होता है. But when you take the tertiary haloalkanes, यहाँ पे ज्यादा चांस होता है कि elimination reaction होता है. और यहाँ पे जब elimination reaction होता है तो किस टाइप का एलिमिनेशन रिएक्शन होता है, डिहाइड्रोहैलोजनेशन, मींस हाइड्रोजन फ्रॉम द हाइड्रोजन एंड योर हैलोजन ग्रुप यहाँ से रिमूव हो जाते हैं. सपोज वी जस्ट टेक सेम एग्जांपल, लेते हैं दिस इज योर एक्स, राइट. तो यहाँ पे क्या होता है, व्हाट हैपेंस हियर, बिकॉज यहाँ पे आप स्ट्रॉन्ग बेस दे रहे हो, तो इन द प्रेजेंस ऑफ अ स्ट्रॉन्ग बेस व्हाट हैपेंस, तो यहाँ पे सब्स्टिट्यूशन नहीं होगी, यहाँ पे आपका एलिमिनेशन रिएक्शन होता है. द हाइड्रोजन फ्रॉम दिस, सपोज यहाँ पे आपका एक हाइड्रोजन यहाँ से रिमूव होके एंड द हाइड्रोजन फ्रॉम देयर, so HX will be removed, and if HX will be removed, so obviously यहाँ पे क्या आ जाएगा, डबल बॉन्ड, राइट. तो यहाँ पे एलिमिनेशन रिएक्शन होता है और यहाँ पे डबल बॉन्ड आ जाता है, मींस यू विल गेट द एल्कीन. ओके, सो मोर चांसेस होते हैं कि यहाँ पे एलिमिनेशन रिएक्शन है, बट थोड़ा बहुत आपका अल्कोहल्स भी बनता है, एंड अल्कोहल्स इज अ माइनर प्रोडक्ट. अल्कीन विल बी योर मेजर प्रोडक्ट एंड अल्कोहल विल बी द माइनर प्रोडक्ट, इसलिए हम इसे प्रेफर नहीं करते. व्हाट इट.
Yes, ma'am.
Okay, let's move to the next one. Okay, write down the third methods of preparation, and this is very important. From carbonyl compounds. From carbonyl compounds. That's the third method of preparation. First, we have done it with the alkene. Then second is here from haloalkane, and the third one is here from carbonyl compounds. So
Ma'am,
this
uh,
yes,
for the third degree alcohols, for the method of preparation, alcohols and alkene are formed both, but in which is major and minor? Alcohol is minor, right?
yeah, yeah.
Okay, thanks, ma'am.
Basically mixtures milte hain, so that we don't prefer it. But just remember
Okay.
that. Third one is here
Okay.
from carbonyl compounds. From carbonyl compounds. Now, what is carbonyl compounds, Ahil?
Uh, are like aldehyde ketones part of it, like that?
Yeah, so basically aldehydes and ketones को हम carbonyl compounds कहते हैं. Aldehyde and ketones. So we will see how we can prepare the alcohols from aldehydes and ketones. Okay, so first write down by the reduction of aldehydes and ketones. आप जब रिडक्शन कराते हो किसी भी रिड्यूसिंग एजेंट के प्रेजेंस में, so you will just convert this aldehyde or ketones into your corresponding alcohol. Suppose if we take in the presence of any reducing agent, so what will happen, you will get, suppose यहाँ पे क्या है, this is your hydrogen, right? And so you will get here corresponding alcohol. What is reduction, Ahil? What is oxidation and reduction? आप simple reduction बताओ. What do you mean by reduction?
Loss of hydrogen.
Yes. Loss of hydrogen.
Hydro
Reduction. Loss of hydrogen is reduction. Are you sure?
uh,
What's the difference between oxidation and reduction?
Reduction is the loss of hydrogen, right?
No, addition of
No.
hydrogen. बच्चे.
Addition of hydrogen.
Addition.
Okay.
Addition of hydrogen is your reduction and removal of oxygen.
Oh, yes, yes, yes.
Yeah, so it's
Yes,
just
sorry.
opposite.
Oh,
ऑक्सीडेशन
yes.
क्या होता है या तो ये पहले समझना जरूरी है, व्हाट इज ऑक्सीडेशन एंड व्हाट इज रिडक्शन. सो ऑक्सीडेशन इज when you are talking about in terms of electrons, so loss of electron is your oxidation and your gain of electron is your reduction, right? And addition of oxidation की बात होती है तो वहां पे addition होता है ऑक्सीजन. Okay, so just opposite क्या होता है यहाँ पे, removal of oxygen. Removal of oxygen is the reduction,
Oxygen.
and
Yeah.
oxidation is removal of hydrogen. Oxidation is removal of hydrogen and reduction is addition of hydrogen. आप hydrogen add करते हो, then it is known as your reduction. Okay, so we are
Yes,
talking
ma'am.
about the reduction of aldehyde and ketones. Okay, तो यहाँ पे reduction होगा means the addition of hydrogen. यहाँ पे हाइड्रोजन का एडिशन होगा. ओके, सो जस्ट ये ध्यान रखना. ओके, सो दैट्स व्हाई मैंने यहाँ पे शो किया था, ये हाइड्रोजन को आप ऐड कर दो, यहाँ भी हाइड्रोजन को ऐड कर दो, राइट? सो यू विल गेट अ करस्पॉन्डिंग, बिकॉज रिड्यूसिंग एजेंट के प्रेजेंस में कर, तो रिड्यूसिंग एजेंट क्या करता है, ये ऐड कर देता है हाइड्रोजन को, एडिशन ऑफ हाइड्रोजन होता है. एंड ये खुद तो रिड्यूस, खुद तो ऑक्सीडाइज होता है, बट ये इससे रिड्यूस करा देता है. दैट्स द रिड्यूसिंग एजेंट. ओके, सो दैट्स द
Yeah.
रिड्यूसिंग एजेंट. ओके, सो यू विल गेट, यहाँ पे ऑक्सीजन के साथ बॉन्डिंग बना लेगा हाइड्रोजन, एंड यहाँ पे भी एक हाइड्रोजन आ जाएगा, तो यू विल गेट दिस हाइड्रोजन, राइट? एंड दिस बॉन्ड विल ब्रेक, ये बॉन्ड ब्रेक होगा एंड यू विल गेट दिस. ओके, सो दिस इज योर अल्कोहल. नाउ सी, aldehydes and ketones, they can be easily converted to alcohol using suitable reducing agent. And क्या क्या reducing agent हम use कर सकते हैं? So see, write down first, aldehydes and ketones can be easily converted to alcohol using suitable reducing agent. Reducing agent, such as, write down the example. You can use H2. H2 in the presence of, either आप use कर सकते हो nickel as a catalyst, palladium as a catalyst, or platinum. Okay, hydrogen H2 with either nickel or palladium or platinum, and this is also known as your catalytic hydrogenation. Hydrogenation. Hydrogenation is addition of hydrogen in the presence of catalyst. Okay, so catalytic hydrogenation
Yeah.
in the presence of the catalyst like your nickel, palladium, or platinum. Second, आप use कर सकते हो reducing agent. The most strong reducing agent is lithium aluminium hydride, right? LiLH, कि आप सिंपल LaH भी बोलते हो आप इसे, lithium aluminium hydride. So it's a strong reducing agent. नेक्स्ट आप यूज कर सकते हो सोडियम बोरोहाइड्राइड. ओके, NaBH4, सोडियम बोरोन हाइड्राइड. एंड वन मोर reagent आप यूज कर सकते हो रिड्यूसिंग एजेंट, सोडियम in presence of ethanol. In presence of ethanol मीन्स आप एरो पे ऐसे लिखा होगा, अगर सोडियम इन द प्रेजेंस ऑफ C2H5OH, सो दिस इज अगेन अ रिड्यूसिंग एजेंट. ये भी क्या करेगा, रिड्यूस करा देना आपको. when you see this on the arrow, sodium in the presence of C2H5OH. Yeah, so you can use these
Yes, ma'am.
reagent as a reducing agent. Now let's do some questions. Suppose we have an aldehyde or CH. Aldehyde, when you are using the reducing agent, So what will happen? What will happen over here? So you will get this CHO. यहाँ पे क्या होगा? Addition of hydrogen. यहाँ पे एक hydrogen add होगा, यहाँ पे एक hydrogen add होगा, and you will get R, and this bond will break. यहाँ पे क्या करेगा? ये आपका pi bond break हो जाएगा, and you will get R CH2, and यहाँ पे भी hydrogen OH. So this is your primary alcohol. Means the reduction of aldehyde will give you a primary alcohol. Reduction अगर आप aldehyde का कराओगे तो you will get primary alcohol. Now, see, if we do the reduction of ketone, suppose this is your ketone CO, और यहाँ पे कोई भी H नहीं लगा है, अगर H लगाओगे तो आपका aldehyde हो जाएगा. Suppose R dash, R and R dash. When you reduce this, आपने कोई भी reducing agent डाला, so what will happen? यहाँ पे क्या होगा? Again hydrogen, यहाँ पे भी hydrogen, right? So in this type, so you will get basically आप कैसे से लिख सकते हो? यहाँ पे R, this will get, this carbon will get hydrogen, okay, and here
Yeah.
again the other R dash, and here
Yeah.
OH group is there.
Which, yeah.
Now in this case, when you reduce, the reduction of ketone will gives you secondary alcohol. Okay, so just remember the difference between. You will get the secondary alcohol. So aldehyde on reduction will give you primary alcohol, and the ketone on reduction will give you secondary alcohol. Is it clear?
Yes, ma'am.
Okay, now you can write to aldehyde gives primary alcohol on reduction. Ketone gives secondary alcohol on reduction. Okay, see, one more thing. यहाँ पे देखो lithium aluminum hydride and sodium borohydride. So which is more strong? So lithium aluminum hydride is more strong. ये strongest होता है reducing agent. So when you compare these two, lithium aluminum hydride and sodium borohydride, so lithium aluminum hydride is more strong than sodium borohydride. Why? Now the question is why. So here you can see lithium aluminum hydride. Lithium के साथ क्या है? Aluminium है यहाँ. So aluminium
Yeah.
is less electronegative than boron. When you compare the boron and aluminium, so aluminium is less electronegative than boron. So the aluminium और hydrogen की जो bonding होगी lithium aluminum hydride में, वो more polar होगी. That is more polar, right? So
Yeah.
thereby this the more polar bond aluminium and hydrogen, this bond is more polar, so it makes the lithium aluminum hydride a strong reducing agent as compared to the sodium borohydride. ओके, सो लिथियम एल्यूमिनियम हाइड्राइड ये सबको रिड्यूस कर देगा. इट इज स्ट्रॉन्गेस्ट रिड्यूसिंग एजेंट, ये सबको रिड्यूस कर देगा, राइट? बट सोडियम बोरोहाइड्राइड ये सिर्फ कीटोन एंड एल्डिहाइड को रिड्यूस करेगा. ओके, ये इतना पावरफुल नहीं होता कि ये कार्बोक्सिलिक एसिड को भी रिड्यूस कर, राइट? सो जस्ट रिमेम्बर, अगर कार्बोक्सिलिक एसिड है और सोडियम बोरोहाइड्राइड है, तो वो सोडियम बोरोहाइड्राइड के अंदर की कैपेबिलिटी नहीं है कि वो कार्बोक्सिलिक एसिड को कर दे, right? Because carboxylic acid में क्या है? COOH. And what is the reduction? The removal of oxygen. तो एक ऑक्सीजन है, यहाँ पे two ऑक्सीजन, right? तो उसके लिए strongest reducing agent की need होगी to remove these two oxygen. So sodium borohydride as compared to lithium aluminum hydride is not as much stronger than the lithium aluminum hydride. So it will only reduce the ketone and aldehyde, but lithium aluminum hydride, it will reduce every compound. Okay, either it will be ketone, aldehyde, ester, सबको कर देगा. Clear, Ahil?
Yes, ma'am.
Okay, now let's do the question. So ketone gives secondary alcohol on reduction. Okay, and yeah, one more thing, the number of carbon atom will remain same. Carbon atom में कोई changes नहीं आएगा, बस क्या होगा? Hydrogen increase हो जाएगा. Hydrogen increase हो रहा है. So will remains same. Okay, let's do some question. You have to
Could
write
you
it.
about that lithium aluminum hydride? Could you write a sentence like a note for it?
Yeah, yeah, sure. Okay, write down in a note. LAH is more stronger, more stronger reducing agent than NaBH, sodium borohydride, right? Is more stronger than sodium hydride. Why? Because aluminium is less electronegative than your boron. So the aluminium and hydrogen bond in lithium aluminum hydride is more polar in nature. Polar in nature due to the difference in the electronegativity. So thereby making lithium aluminum hydride a strong reducing agent. One more point you can add that hydride will reduce everyone everyone or every compound you can write, but NaBH4 will reduce only RCHO aldehyde and R. This is your ketone. NaBH4 and H2, right? H2 means catalytic, the presence of catalyst. Recombination way, they do not convert, yeah, यहीं पे लिख लो आप carboxylic acid to alcohol. Sodium borohydride and this hydrogen in the presence of catalyst means a catalytic hydrogenation will not convert the carboxylic acid to ethane or your corresponding alcohol. So we will use the lithium aluminum hydride to convert the carboxylic acid to your corresponding alcohol. Clear, Ahil?
Yes, ma'am.
Because we are not discussing here the only we are talking about the carbonyl compounds. तो यहाँ पे अभी हम डिटेल्स में बात नहीं करेंगे कार्बोक्सिलिक एसिड का. When we discuss the carboxylic acid preparation, then we will do that.
Yes, ma'am.
Okay, so okay, we were discussing the questions. So write down the question. First question. Write the major product for the following. First question. CH3, CH2, and this is CH2 in the presence of this. ये आपको major product लिखना है. CH3, CH, CH3, and here I'm attaching to CH2 in the presence of lithium aluminum hydride. Third, CH3, that's a ketone, CH3 in the presence of NaBH4, sodium borohydride. Fourth one, suppose ये कितना है आपका, and in the presence of sodium and ethanol. Okay, write down. Fifth one, CHO in the presence of H2 and platinum catalyst. Sixth question, you do this question.
Ma'am, is the first one CH3, CH2, CH2OH?
Okay. Second one,
Ma'am, could you give me a second? My mother is.
see the second one. What you're supposed to do is CHO. Okay, the number of carbon should be same. But what happens is carbon के पास एक hydrogen आएगा and this oxygen के पास एक hydrogen आएगा. Right? So attach. You have to attach two hydrogen at a time. To this carbon, just attach one hydrogen, and to this hydrogen, attach this hydrogen. So what will be the product? This chain as it is, you will write this as it is, and here you will get CH2. Hydrogen एक पहले से ही था, and you are attaching one hydrogen over here. CH2 and OH.
Yeah.
Clear?
Yes, ma'am.
Third one, you have to attach two hydrogen. One to this
Yeah.
carbon, one to this carbon. ये bond break होगा. यहाँ पे एक hydrogen attach करो and यहाँ पे OH.
OH.
You will get CH3, CH, CH3, and here OH. Yeah, so in the case of, in the reduction, when you reduce the ketone, you will get the secondary alcohol, and when you reduce the aldehyde, you will get the primary one. Fourth question. Again, the same thing.
Same thing. The OH will be
Yes.
there in place of. So,
Yeah. So, which will be attached. Number of carbon should be same. Okay, number of carbon increase नहीं होगा. Only आपको two hydrogen
yeah.
add करना. Okay, so क्या हो
Will
जाएगा?
be
One, two,
CH2OH.
yeah, CH2. और सिंपली आप ऐसे भी लिख सकते हो, दिस 1 2 3, and this is fourth carbon, 1 2 3 4 carbon here, OH. Next one.
Yeah, OH will be in place of
This one.
CH2OH.
Yes. Yeah, in this question, lithium aluminum hydroxide hydride is strong reducing agent. So it will reduce both. ये aldehyde को भी reduce
Oh,
करेगा and इसे भी reduce करेगा. अगर if in the compound both the substitution, you can say both the aldehyde भी है वहाँ पे functional group and the ketone is also there. So lithium aluminum hydride will reduce both. Okay, or sodium borohydride will also reduce. तो सोडियम हाइड्रो बोरोहाइड्राइड इसे रिड्यूस करता है एल्डिहाइड एंड कीटोन्स. ओके,
yes.
नाउ इफ इन द क्वेश्चन सपोज आहिल, इफ मैं यहाँ पे सपोज इट इज कीटोन, ना यहाँ पे अगर मैं कार्ब सी डबल ओएच लगा दूं एंड इफ आई गिव यू द रिड्यूसिंग एजेंट इज सोडियम बोरोहाइड्राइड, नाउ व्हाट विल बी इन दिस सिचुएशन, व्हाट विल बी द सी सोडियम बोरोहाइड्राइड हमने यूज किया है.
Yeah,
Yeah, so it will reduce only aldehyde and ketone,
one.
not
Yeah,
the carboxylic acid. So carboxylic
yeah,
acid as it is रहेगा, you will get this product, right? So OH will be
yeah,
here and यहाँ पे. Okay, so सबसे पहले आपको ध्यान में रखना है which reagent is given, which reducing agent is given in the question, and accordingly just write down the product. So in this question you will यहाँ पे OH and here
yeah, and OH.
this one.
But it will reduce both aldehyde and ketone, right?
CH2.
Yeah.
Now is it clear now?
Yes, ma'am.
Okay. Okay, so this from the carbonyl compounds, we can prepare the alcohol by the reduction of aldehyde and ketones. Now the second one, write down when that was the first one by the reduction of carbonyl compound. The second is the reaction of carbonyl compound with Grignard reagent. जब आप Grignard reagent से react करते हो carbonyl compound, so again you will get the alcohol. Okay. Now see. So we have a Grignard reagent. Suppose we have a carbonyl compound. So carbonyl compound CO. अगर यहाँ पे मैं HH लगा दूँ या suppose यहाँ पे H लगा दूँ, यहाँ पे R लगाऊँ, this will be aldehyde. And if only R and R लगाऊँ, so this will be ketone. So I'm not writing. I'm just writing the general carbonyl compound, right? So when you take the general carbonyl compound and when you treat it with Grignard reagent, what is Grignard reagent? RMGX. Okay, RMGX. Now see, whenever the carbon is attached to the metal, so metal will attain, because metal क्या है यहाँ पे electropositive है, right? So it will achieve partial positive charge, right? And this
Yeah,
carbon of the alkyl group will get partial negative charge. You know very well. Now in this oxygen is more electronegative, right? तो ये क्या करेगा, अपने तरफ इसे pull कर लेगा electron, so this carbon will have plus charge. Now what will happen, this R group, this alkyl group is negative charge, so ये क्या करेगा, इसे कार्बन पे अटैक करेगा, and you will get this R will be attached to this carbon, and here O पे minus charge, right? And this Mg plus and X, Now in the second step, when you water आप अगर इसमें put करोगे, okay, hydration कराओगे, so what will happen, we know that it has OH minus and H plus ion, H plus and OH minus ion, right? So H plus will goes to this oxygen and OH will goes to this Mg. So what will be the product? So you will get, तो यहाँ पे H hydrogen यहाँ पे attach हो जाएगा and R will be there, and plus MgOH. This will be your byproduct. Mechanism clear?
Yes, ma'am.
So that's how when you react the carbonyl compound with the Grignard reagent, again you will get the alcohol. So what you are supposed to do? आपको ये पाई बॉन्ड जो है कार्बन एंड ऑक्सीजन का ये पाई बॉन्ड ब्रेक करना है एंड देन टू न्यू बॉन्ड्स आर फॉर्म between the carbon and R group, right? So suppose this carbon, this pi bond को आपने break करना है, right? And the new bond will be formed between C and R, alkyl group, okay? And oxygen and hydrogen. Between the oxygen and hydrogen, these two bond will be formed, and these two carbon and oxygen pi bond will be break. So it's very simple now.
Oh. Ma'am, could you give me
As
one
it is,
second? I need to write.
yeah, okay. Okay, again, this is a two-step reaction. Okay, so the first step, the reaction with carbonyl or your Grignard reagent. In the second step, अगर एग्जाम में मैकेनिज्म नहीं पूछा है तो just remember this trick. Okay, what you're supposed to do, just break the pi bond, okay, of the carbon and oxygen and just make these two new bonds. आपको दो new bond formation करना है, carbon with carbonyl R group, alkyl group and oxygen with hydrogen. Very simple.
Yes, ma'am.
Any doubt in this mechanism?
No, ma'am.
Now we have done with the general formula. Now see, for the carbonyl compound, suppose if there is a H hydrogen and hydrogen. Hydrogen is attached to this carbon, and in the next, if we attach one hydrogen, right, one hydrogen and one alkyl group over here, so this will be your aldehyde. Okay, this is your HCHO. HCHO क्या होता है आपका formaldehyde. This is your
Yeah.
formaldehyde. So we will see one by one क्या reaction होगा when you treat the your what we call it, yeah, Grignard reagent with formaldehyde or with other aldehyde and with ketone. So what will be the reaction and what will be the mechanism? We will see one by one. So this is your aldehyde. ठीक है आपका general aldehyde है. Formaldehyde is again a aldehyde, but this is a aldehyde. ये any other aldehyde you can write. Other aldehyde. And the third one is अगर आप यहाँ पे two different alkyl groups or same alkyl groups if you attach to this carbon, so this will be okay, right? This is your ketone. Let's see one by one what will be the reaction of these three with the Grignard reagent. First one, okay, आपको ये trick भी याद रखना है. Suppose if we in the question they just give you the formaldehyde, so you have to remember that when you treat the formaldehyde, suppose this is your formaldehyde, right? HCHO. When you treat it with in the presence of your RMGX, RMGX is your Grignard reagent, and the second step is your hydration कराते हो. So what will be the product? What we are supposed to do? Just break this pi bond. Okay, ये pi bond को break कर दो. Okay, and this pi bond will be break and just oxygen and hydrogen. This one bond is formed between the oxygen and hydrogen, and another bond will be formed between the carbon and your R group. R group of the alkyl group of the Grignard reagent. That's your product. That's your product. और इसे आप कैसे लिख सकते हो? This is your R, C, and carbon पे two carbon hydrogens are there. So it's R, CH2OH. Right? So this will give you primary alcohol. This is your primary alcohol. So just remember, always when the formaldehyde, when you treat it with the Grignard reagent, so you will get a primary alcohol. Clear?
Okay, ma'am.
Second one. Let's see when there is another aldehyde. अगर आपका हाइड्रोजन वन हाइड्रोजन को आप रिमूव करा दो रिप्लेस करा दो किसी भी अदर अल्काइल ग्रुप के साथ so it will be other aldehyde. So what will happen? So okay, first you can write this is the यहाँ पे ये हेडिंग लिख लेना वन लिख के so it's a RMGX plus formaldehyde it will give you a primary alcohol. पहले आप ये लिखना देन उसके बाद रिएक्शन लिखना will give you primary alcohol. Next step, next see. So when our Grignard reagent, when you treat it with other aldehyde, so always remember you will get the secondary alcohol. Secondary alcohol. Okay, let's see. कैसे secondary alcohol आपको मिल रहा है. So suppose we have your R and this is your H. Okay, this is your RCH, other aldehyde, and O here, right? And when you treat it with, and because you are taking the R over here, तो आप Grignard reagent में R dash लिखना, R dash MgX, and in the second step, water. Okay, so what will happen? Again the same thing, just break the pi bond. Okay, just break this pi bond and make new bond with hydrogen. OH यहाँ पे attach हो जाएगा and the other bond will be formed between the carbon and the R dash. R dash means the alkyl group of the Grignard reagent. So this will be R dash. Right. So what is this? So आप इसे ऐसे भी लिख सकते हो. It's carbon CH and here R group and here the R dash. Right. So this is your basically you can write. ये क्या है आपका secondary alcohol. This is your secondary. Yeah, so when you treat the Grignard reagent to other aldehydes, you will get a secondary alcohol. But if you treat it with the formaldehyde, so always you will get the primary alcohol. That's the difference. Clear, Ahil?
Yes, ma'am.
Okay, let's see the third one. जब आप कीटोन को treat कराते हो Grignard reagent में. So suppose if we take the Grignard reagent RMGX, when you treat it with ketone, yeah, so you will get the tertiary alcohol. You will get the tertiary alcohol. See how? Suppose we have R, CO, and here other R dash. Okay, two different alkyl or same भी हो सकते हैं alkyl groups. R dash. So first step, Grignard reagent. Because you are taking the R and R dash, तो आप Grignard reagent को आप R2 लिख सकते हो. Okay, to differentiate between the alkyl groups. So R2 MgX. Second step, water. Again the same thing. Do the same thing. Break this bond. So R dash as it is. OH over here and this R. This is your R2. Right. So what is this? This is your tertiary alcohol. Tertiary alcohol. Yeah. So just remember that when you treat the Grignard reagent with formaldehyde, primary alcohol मिलेगा. Then when you treat the other aldehyde, means other than the formaldehyde, with the Grignard reagent, you will get the secondary alcohol, and when you ketone को treat कराओगे, you will get the tertiary. Clear, Ahil?
Yes, ma'am.
It's important. Just remember that. Okay, let's do questions. So you have to write down the product of the following. Write the products for following. First one, HCH, formaldehyde, and the Grignard reagent, CH3MgBr. Okay, so just write down the product. Second question. Okay.
Ma'am, the first one it will be uh ma'am, the first one will be HCHO and CH3 will be attached to it, right? Like I don't know.
CHO. Basically, see,
Like H bonded to C bonded to OH, and then carbon is bonded to hydrogen and CH3. Like
let's see, simply it will be just a second. For one carbon CH. So basically आप अगर ऐसे बनाओगे कार्बन, this is a
yeah, and
CH,
OH.
right? Right. What will happen? This CH3 MgBr, right? So this CH3 is your R group. This bond will be break और यहाँ पे क्या आ जाएगा आपका हाइड्रोजन, right? Hydrogen, and
Yeah,
this CH3
will
will
be
be
attached to the
attached to this
carbon.
carbon, right?
Yes, ma'am.
So
Yeah,
this CH3 and here OH. So आप इसे कैसे arrange करके लिख सकते हैं? You will get CH3 and this to this carbon there are two hydrogens. So CH3 CH2 OH. This is the ethanol, right? So this is your ethanol. आपको ethanol मिले.
yeah,
Clear?
yes, ma'am.
Yeah. So in your exam, after this mechanism, just rearrange the atoms and उसको आपको easy format में लिखना है, simplest form में. So
Okay.
basically, you will get CH3, CH2H. Next one. This is your
This one will be
1, 2 carbon. It will be same,
yes,
but there are two carbons. 2 carbon plus 1 carbon means it will give you,
CH3, CH2, CH2OH.
yeah, propanol.
Yeah.
Okay. Next one. यहाँ पे देखो आप branching है.
Yeah.
You can see the magnesium is
So
NGCl is attached to this. So this is basically, this is your alkyl group. CH3, CH and CH. इससे आप attach करोगे to this carbon, right? You
yeah,
can write like this. Right, फिर से bond break करो, यहाँ पे आप लगा दो OH and यहाँ पे क्या attach हो जाएगा, this CH3, 3 carbon chain यहाँ पे. See this 3 carbon chain. So you will
yeah,
get CH. Yeah, so this is your, यहाँ पे क्या है, CH, CH3, CH3. Now you can rearrange this. So you will get CH, यहाँ पे CH3, CH3, and this is your CH2. This is your product. Okay,
yes, ma'am.
very simple it is. Next one.
This one is it'll be CH3.
First, first carbon, second carbon, right?
Yeah,
So this CH3, CH2, basically यहाँ से arrange होगा, यहाँ से attach करोगे आप CH2 की तरफ से. Suppose this is your third
yeah,
and fourth carbon. So you will attach this CH3 and this bond will break, and here you will OH. This is a hydrogen, and here you will attach this CH to CH. Okay, and you can write
yeah,
this CH3 CH. This is your CH OH, and or simply आप ऐसे लिख सकते हो, just a second. CH3 CH. This is CH2. This is the longest chain, parent chain, and on the second carbon position there is a hydrogen. Okay, so this is the final answer. Clear, Ahil?
yes, ma'am.
Third one,
This one.
to this carbon
Uh,
position. The
yeah.
attachment will be from this carbon to this carbon, right?
Yes, ma'am.
So what will
So it will
happen?
be in place of where the ketone is, there will be OH, and then below that carbon, we'll have the ring.
Yeah. So hydroxyl group OH will be there, and from यहाँ से attachment होगी, so it will be like this. So that is the final answer. Clear?
Yes, ma'am. Yes, ma'am.
So to this carbon and this carbon, this will attached. तो यहाँ पे attachment करनी शुरू करें. Suppose this is your first, 2 and 3. And suppose this is your first. Okay, one carbon, one carbon. So basically 2 and 1. The second carbon of this first molecule and the first carbon of this cyclic molecule. So in दोनों का arrangement हुआ है. This is your 2 and this is 1. Okay,
Yes, ma'am.
one more question. Suppose if I give you this one, ketone plus this MgCl in the presence of water. Okay, then what will be the answer? One will be break. It's very
Ma'am,
easy.
the answer will be
OH here,
in
right?
yeah, yes, ma'am,
And this
and
carbon will be attached to this carbon. यहाँ पे क्या हो जाएगा? This type of a thing, just like this.
yes, ma'am.
This carbon will attach to this carbon. ये carbon यहाँ पे 3 carbons. So these two carbons are just like a substituent. just like a substituent है यहाँ CH3 CH3 and this carbon they just attach each other. यहाँ पे bonding हो जाएगी. Right, so this is the final answer. Okay, so
Yes,
this
ma'am.
concept
Okay.
is clear. Any doubt in this?
No, ma'am.
Okay, one more question. I'll convert. Question is convert. Sometimes conversion इस type के भी questions आते हैं, like convert ethyl bromide to propanol. To propanol. So how you will convert the ethyl bromide to propanol? You see, first, what is ethyl bromide? So one carbon, two carbon, and bromine over here, right? So you can convert first this ethyl bromide से आपको किसमें convert करना है? Propanol.
So
Okay.
aqueous KOH. Yeah.
Yeah. Yeah. So basically आप two step में भी कर सकते हो. First step आप ऐसे भी कर सकते हो simply in the presence of aqueous NaOH or aqueous KOH you will get this product. Okay, you will get this. No, just a second, Ahil. Just a second. You are telling that this is your question. Ethyl bromide से आपको propanol में करना है. So that's a this is your propanol. But see,
Propanol. Okay.
yeah, but see when you use aqueous
Oh yeah,
aqueous
carbon won't be
NaOH,
added. Yeah,
yeah. Okay, so
carbon.
aqueous KOH क्या तो क्या होगा आपका? This will be your OH. One carbon is add हो रहा है वहाँ पे one carbon. Okay, so this will in when you use the aqueous KOH or aqueous sodium hydroxide, so you will get the same number of carbon. But यहाँ पे क्या हो रहा है? Number of carbon is increasing. So what you are supposed to do? आप क्या कर सकते हो? First, you will use the to make it a Grignard reagent. Okay, तो आप इससे metal के साथ react करा. Okay, so ethyl bromide means your alkyl bromide when it reacts with metal just like a magnesium. जब ये magnesium के साथ react करता है तो it just form Grignard reagent. When alkyl halide when you treat it with magnesium metal so it will give you a corresponding Grignard reagent. तो क्या हो जाएगा आपका Grignard reagent? So this will be your Mg यहाँ पे attach हो जाएगा. This will it's very easy. आपने देखा है अभी ग्रिग्नार्ड रिएजेंट को आप किसके साथ ट्रीट कराओगे सो यू विल गेट द प्रोपेनॉल. व्हाट यू आर सपोज्ड टू डू व्हेन दिस इज टू कार्बन चेन the Grignard reagent in this Grignard reagent the alkyl group R group has two carbon two carbon but in the product part हमें प्रोडक्ट क्या बनाना है प्रोपेनॉल बनाना है मींस वन कार्बन
Three
हमें
carbon.
ऐड करना राइट वन कार्बन हमें ऐड
Yeah.
करना वी हैव R group which has two carbon. Now हम one carbon कैसे ऐड करें? So can we treat it with aldehyde formaldehyde? Yeah. So one carbon के साथ हम treat करा देंगे with the one carbon aldehyde is basically a formaldehyde, which only one carbon is there, right? So we
Yes, ma'am.
can treat it with the formaldehyde in the presence of water, right? Basically, you will get this. That's very easy, right? And you know very well the mechanism will be HCHO. यहाँ पे अगर आपने HCHO है and when you are treating it with MgBr, this is your two carbon chain, right? So this bond will be break और यहाँ पे OH लग जाएगा and this CH2 group over here, right? So basically this is your CH2 CH3. This is nothing but a CH2 CH3. Okay, so what is this? This is nothing but a propanol. क्या है प्रोपेनॉल है आपका
Yeah.
CH3 CH2 CH2OH. This is your propanol. That's how you just get the propanol. Clear?
Yes, ma'am.
So this type of question can come. Conversion questions बहुत आते हैं boards. So be prepared for that.
Yes, ma'am.
Yeah. So more question you will practice, आपको उतना ज़्यादा clear होगा. So I will always suggest you just after the class, just sit, open your NCRT book, just find a previous year question and जो भी आपका topic आज हुआ है cover, उससे related जो भी questions हैं, just try to solve the question. Right? जितना questions आप practice करोगे आहिल, उतना ज़्यादा आपको easy हो जाएगा boards. Right?
Yes, ma'am. Yes, ma'am.
Because chemistry is very conceptual. इतने सारे chapters हैं, you will basically आप forget, आप भूल जाते हो आप concept in exams, right? So जितने practice करोगे उतना ज़्यादा आपका आप strong होता जाएगा concept, उतनी understanding उतनी clear होती जाएगी.
Yes, ma'am.
Okay, so the next one, okay, I will give you some questions based on this. Please try to submit that homework. आप homework submit नहीं करते हो, मैंने देखा है. Next, write down
Yes, ma'am.
the next preparative method. I think that was the fourth one, right? Fourth, I think, yeah. From the carboxylic acid. Fourth preparative method is from carboxylic acid. Now, when carboxylic, again, we will reduce the carboxylic acid. So when carboxylic acid is reduced using lithium aluminium hydride, it will convert to primary alcohol. Okay, and with the same number of carbon atoms will not be increased or decreased. So write down when carboxylic acid is reduced using lithium aluminium hydride, because we know very well sodium borohydride will not convert the carboxylic acid to the alcohol. It converts to primary alcohol with same number of carbon atoms. Okay, let's see the general reaction. Suppose we have a carboxylic acid RCOOH. Okay, when you reduce, when you are using the reducing agent lithium aluminium hydride, so it will be reduced means यहाँ पे क्या होगा, these two oxygen. Yeah. What will happen over here? यहाँ पे reduction होगा and this will
Yeah.
reduce to corresponding CH2OH. CH2OH. Okay, means the addition of two hydrogen. यहाँ पे बस आपको क्या करना है, simply just remove one oxygen and add two hydrogen. You will get the corresponding alcohol. Okay.
Yes, ma'am.
For example, suppose we have this COOH and this carbon is a part of the chain. Okay, carbon is the part होता है chain का, on the carboxylic acid में जो carbon है. So when you treat it with lithium aluminium hydride, so what will be the product? Write down. Similarly, structure same lithium aluminium hydride. अपने product लिखना है. Third one. So benzoic acid. Okay, benzoic acid को जब आप reduce कराते हो, so what will be the product? And Ahil, tell me the first answer.
Last question, ma'am. Also.
Okay.
And the first answer will be there'll be CH2OH in place of COH.
Yeah. Yeah. Next one.
It'll be the same CH2OH in place of COH.
this benzoic acid will convert to the benzoyl alcohol.
Yeah.
Next one.
Same CH2OH will be there.
CH2OH will be there for the carboxylic acid, and we know that lithium
Yeah.
aluminum hydride also reduce the ketone. यहाँ पे ketone भी तो है,
Yes, ma'am.
right? So it will
Yeah.
reduce ketone also, right? OH over here and here CH2OH,
Yeah.
right? Yeah. So always remember sodium borohydride and hydrogen. If the reagent is sodium borohydride or hydrogen, okay, in the presence of nickel or whether palladium or platinum catalyst, so they do not convert the